In today's lesson, we're just going to look at a couple of more ways that we can use trigonometry to solve problems. So Chase is putting a fence around his yard. We want to determine how much fence he is going to need. Well, we know that this side here is 20, and these markings mean they're congruent, so this side will also be 20. And then we've got 14 along the bottom. Problem is, we do not know the lengths of these two sides here, so we are going to have to find them. What we can do is we can create a right triangle. What we know is if this whole angle is 130 degrees, we know that the properties of rectangles are that they intersect at 90-degree angles. 130 minus 90 leaves us with 40 degrees for this part in our right triangle. The other piece of information we know about a property is if this side here is 14, then the side directly opposite will also be 14. So we do now have enough information to solve for x and y. So we can label this triangle according to that 40-degree angle. The 90-degree angle points at our hypotenuse. The angle across from it is opposite side, and then we have our adjacent side. So now it really does not matter whether we solve for the opposite side or the adjacent side first. You're going to have to do both calculations. And we have enough information to do both calculations. So if I'm going to solve for the opposite side first, we're going to look for the opposite. We know the hypotenuse. So sine uses opposite and hypotenuse. So sine of 40 is equal to x over 14. Sine of 40 is 0.64278 equals x over 14. We're going to solve for x by multiplying by 14 to both sides. And so therefore we will have 8.99 or 9 equals our x. So now we're going to repeat the process with the y. We're looking for our adjacent. We know our hypotenuse. So we are going to use the cos ratio because cos is adjacent over hypotenuse. Cos of 40, our adjacent side is y, our hypotenuse is 14. Cos of 40 is 0.7660 equals y over 14. We are going to multiply both sides by 14. And so we will get an answer of 10.7 equals y. So now to find the amount of fencing, we need to add up all sides of this diagram. So the values that are our sides are as follows. The 14, the 20, the value we just found for y, the value we just found for x, and this 20. So we are going to add all of those up. 20 plus 14 plus 20 plus 9 plus 10.7 gives us 73.7 units, whatever the units are. That is how much fencing Chase will need. One last example, and this will be the most difficult to do. I am not a great artist, so this might be even harder because I'm not going to do a great job of drawing the diagram, but I will try my best to explain it to you. So we have an airplane that's 130 kilometers south and 145 kilometers west of an airport, but it's 9 kilometers in the air. So the first thing I'm going to do is I'm going to earmark the airport, and I'm going to give myself a little bit more room here. So we've got an airport, and on the ground distance, the airplane is 130 kilometers south and 145 kilometers west. So this triangle here is along the ground. So very similar to the previous lesson where we had Idona and Amy and the distance between them, we've got a ground triangle. Now what you have to try and picture, though, is that the airplane is 9 kilometers in the air. And then there's a distance to the airport here. So this is a 90-degree angle to the ground. So that's the hard part to picture at this point. So now what we're going to do, we want to know what is the straight line distance to the airport. So from the airplane to the airport, we want to know what this distance is. But if we look at our triangle here, and sorry, I should have drawn this to this black line, we do not have enough information. We only know one side, and we need two pieces of information. However, we could find the common side. And we can find the common side because we know two other side lengths. And we know if we have two sides of a right triangle and we need a third side, we can use Pythagorean Theorem. The hypotenuse is across from the 90-degree angle, so that is what we are looking for. So we have 130 squared plus 145 squared equals our c squared, or our x. 130 squared is 16,900, plus 145 squared is 21,025. We add those together, we get 37,925. And then we want to square root, so we get 194.7 equals our c, or in this case that was our x. So 194.7. Now we have enough information to find the distance to the airport from the airplane. Once again, we know two sides, and we're looking for the third side. Across from this 90-degree angle is your hypotenuse. So when we are doing a squared plus b squared equals c squared, we've got 9 squared plus 100 squared equals our c squared. 9 squared is 81. 194.7 squared is 37,908.09. Then we add those together, and we get 37,989.09. We square root, and we get 194.9 equals y. So the distance is about 195 kilometers. The next question says, what is the angle along the ground, so we're in our ground triangle, that the airplane is at a direction west of south? So the thing to understand is from the airport, what is the angle that the airplane is at? So that is where we are looking for. Now in this ground triangle, we know all three sides, so we can use any of the trig functions. The important part is that we label our triangle properly so that when we pick a trig function, we use the right values. So across from the 90 degree, there's our hypotenuse. Across from the angle is our opposite, and our adjacent is the other side. So let's use tan. And as I said, it really does not matter. Tan is opposite over adjacent, so we need to use the opposite side we labeled as 145. The adjacent side is 130. So we've got tan theta equals, we divide those two numbers, 1.1153. Then you use the second function tan button on your calculator, and you will get an angle measure of 48.1 degrees. The next question says, what is the angle of elevation of the airplane from the point of view of the airport? So now we go to the green triangle, or the one that is up in the air, so that's the three-dimensional part. We want to know the angle of elevation from the airport. And again, because we know all three sides of this triangle, it doesn't matter which ratio we choose as long as we pull the information correctly. So we've already got the hypotenuse labeled. Across from this angle is the opposite side. Then beside this angle is the adjacent. So it does not matter which we use. If we choose to use cos, we're going to be using adjacent over hypotenuse. So if we use cos, the adjacent side was 194.7, the hypotenuse was 194.9. We divide those two numbers, and we get 0.9989. Do second function cos on your calculator, and you will get 2.6 degrees. The angle of elevation is at 2.6 degrees. You have now learnt everything you need to learn about trigonometry for this level, so you can go and practice this and see how you do.